Okay, in 10.4 we're going to take a look at inverse trig functions. Before we do that, let's review inverse functions in general a little bit. So remember that one of our requirements is that f must be 1 to 1 to have an inverse. Okay, f must be 1 to 1. So remember your function rules. In order to be a function, it has to pass the vertical line test. So for example, a circle is not a function. And if it is a function, like a parabola that passes the vertical line test, in order to be 1 to 1, it's got to pass the horizontal line test as well. We've got to know that for every x there's only one y, and for every y there's only one x. So this one is a function, but not 1 to 1. Okay, so if we have something like a cubic, oops, let's try that again. There's a cubic, so this is a function, passes the vertical line test. It also passes the horizontal line test. Okay, a horizontal line and a vertical line both only hit one time, and so that is 1 to 1. Okay, so we have to have a 1 to 1 function in order for f inverse to exist. Okay, and then we also remember that the domain of f is equal to the range of f inverse. Range of f inverse. And vice versa. Okay, so that's basically saying that the x and y values switch. Okay, so the domain of f is the range of f inverse. The domain of f inverse is the range of f. Okay, and then we remember that the graphs will reflect across y equals x. Okay, so remember we get a certain type of symmetry between a graph and its inverse, and that's that it reflects across the diagonal line. All right, and that comes directly from the x and y value switching. All right, so to find f inverse, we switch the x's and y's, solve for new y, and our new y is the inverse. Okay, so we switch the x's and y's, that goes back up to here where the domain and range have to switch. So that's where we get that we switch the x's and y's, we solve for the new y, and the new y is our f inverse. Okay, so there's some basic inverse rules before we move into the trig functions. Okay, so now let's look at sine of x and recall its graph. Okay, so we remember that we go from 0 to 2 pi, and we cross halfway at pi. We start at 0, we end at 2. We start at 0, 0, we end at 0, 2 pi. Sorry, 2 pi 0, and we're going to go up to 1 and down to -1. Okay, so we've got our sine graph looking a little something like that. That's what we've been typically drawing as the sine graph. You know, when we talk about basically one period. But if you look at this, you realize that it's not 1 to 1. So let me change my color for a second. Okay, it is a function because it passes the vertical line test, but it's not 1 to 1 because we've got repeating y values here and here. So we can't use this to find an inverse. All right, so what we are going to do, let's go back to black. Okay, we need to find a section where we cover all of the values, but we don't repeat any. All right, so if we go, let me redraw it so we can see it a little bit better. Okay, so we have to find a section of sine x, again, where we repeat the values. Where we cover all the values, but we don't repeat any. Okay, so here was our, okay, so there's our sine that we typically look at. All right, so what we're going to have to do is we're going to have to come back a little bit and cover that part as well. Now if we look at this section right here, okay, negative pi over 2 to positive pi over 2, we can see that we cover all of the y values going from negative 1 to positive 1, and we don't repeat any of them. So this section of sine going from negative pi over 2 to pi over 2 gives us a one-to-one function. So we called that a restricted domain. Okay, restricted domain. Okay, so we go negative pi over 2 to positive pi over 2, like that. Okay, and it's closed bracket because that covers everything from negative 1 to positive 1 and everything in between. Okay, and then we also see that our range is negative 1 to positive 1, which is exactly what we wanted. Okay, so now when we look at the inverse of this, let me come back over here. Okay, so now when we look at, okay, so here's sine x. So now when we look at the inverse of sine, okay, the inverse of sine, the domain and range are going to flip. So now my domain is going to go negative 1 to positive 1, and my range is going to go negative pi over 2 to positive pi over 2, and the picture is going to flip. So like that, and it should go like that. Okay, so there's sine inverse of x with domain negative 1 to 1 and range negative pi over 2 to pi over 2. Okay, so what does all of this mean in terms of actually using this? Well, it means that you can plug in any number between negative 1 and 1, which makes sense because we know that we can only have sine values that go from negative 1 to 1. Okay, so the domain makes sense, but the range means that we are only going to get values between negative pi over 2 and pi over 2. So in other words, the fourth quadrant, first quadrant. Those are the only values that we're going to get back from sine inverse x. Okay, so we can write it as sine inverse x, and then another slightly antiquated term is arc sine. Okay, those two things mean the same thing. They're inverse sine. So let's say that we want to find y equals sine inverse of 1/2. Okay, so we've already done some that are like this. We've got sine inverse of 1/2, and we can look at our unit circle or whatever, and we know that theta is going to be 30 when sine is 1/2, okay, or pi over 6 for in radians. Okay, so that one's pretty straightforward. Let's say we have y is equal to sine inverse of 1. Sine inverse of 1. So where is sine equal to 1? That's at, sine is equal to 1 at 90, so sine inverse of 1 is going to be 90 degrees or pi over 2. Okay, y equals sine inverse of negative 1. Okay, now, if we think of our 0 to 2 pi sine, we might answer 3 pi over 2. But sine inverse can't return 3 pi over 2 or 270. It's got to return something between negative pi over 2 and positive pi over 2. So it's going to say negative 90 or negative pi over 2. Okay, so when you're answering these, you can't give any answer for the sine inverse. You've got to remember that it's restricted to values from negative pi over 2 to pi over 2. And then, of course, remember that that we can also get other values by giving more information. So if we were to say y is equal to sine inverse of square root of 3 over 2 in the second quadrant, that gives us a little bit more to work with, because the inverse sign is only going to return fourth and first quadrant values. So we've got to get this in the second quadrant. So remember that the theta is actually a reference angle. So for sine inverse of 3 pi over 2, that's going to be 60. Or pi over 3. But we need our theta to actually be in the second quadrant. So now we know that that's a reference angle. And going off of 180, theta is either equal to 120 or from pi, 2 pi over 3. Okay, so we saw a little bit of that before, but now we see why our values are the way that they are. Okay, now let's look at cosine x. So we'll start with the picture that we know. It goes pi, 2 pi. And we cross at pi over 2, but I'm a little bit cramped for space here, so let's just do the big markings. Okay, we know that it starts up at 1, ends up at 1, and negative 1 halfway. So we get this kind of U-shaped graph for cosine. Okay, now again, this isn't 1-to-1, so it's not going to have an inverse. So we're going to have to do something to make it 1-to-1 so that we can find the inverse. Okay, so we've got to find a section of this that is 1-to-1 and covers all of the values. And for this one, we can look right here. Okay, if we restrict this 0 to pi, okay, that section of cosine is 1-to-1, and we cover all of the values from negative 1 to positive 1. So the restricted domain is going to be 0 to pi, whoops, square bracket, and the range then is negative 1 to 1 with no repeats, which is what we want. Let's try that again. Negative 1 to 1. Okay, so again, we restrict it so that we cover all of the y values, negative 1 to positive 1, without any repeats. So that's our definition for cosine. So now when we look at cosine inverse, we know that we want the domain to be negative 1 to 1, and the range is going to be 0 to pi. Okay, so remember those two things reverse. Okay, so we're going to go from negative 1 to positive 1, and this time our range is going to go from 0 to pi. Okay, so when we invert this, it's going to basically cross at pi over 2 here, and it's going to look off a little bit. You kind of get the idea though, like that. Okay, so again, remember we flip around the diagonal x equals y. So that's going to flip it up into, basically up into the top part of the graph. Okay, so that's what our cosine inverse graph looks like. And then again, we can look for some cosine values. So let's say that we want to do y is equal to cosine inverse of 1/2. Okay, so where is cosine equal to 1/2? It's equal to 1/2 at pi over 6. So we get that theta is equal to pi over 6, or I guess if I'm using x and y, probably x is equal to pi over 6. Okay, either way is fine. Okay, now what if I have y is equal to cosine inverse of negative 1/2? Okay, well you can put this in your calculator, or or you can do it on the unit circle. But remember that the answers that you're going to return have got to be between 0 and pi. So when you do this, you're going to get that theta is equal to 5 pi over 6 or 150. Okay, so it's not going to give you, like, it might seem to make more sense if it would give you a like a negative pi angle, like, or a negative theta angle, like sine does, but it doesn't. It's going to return first and second quadrant answers only. So if you wanted this in the fourth quadrant, you'd have to use that as your reference angle, and then go into the fourth quadrant. All right, so let's look at an example of that. Let's say that we want to do y is equal to cosine inverse negative 1/2 in quadrant 3. Okay, so again, we would get what we would get returned is 5 pi over 6 or 150, and that would tell us that our reference angle is pi over 6 or 30. And then we would have to find that angle in the third quadrant. So we would get 7 pi over 6 or 180 plus 30 is 210. Okay, so that's why I was telling you guys before when you were doing these, and maybe if you're looking for a different quadrant, it may be easier to put in the positive value, because the positive value is going to give you your reference angle, and then from there you can figure out any quadrant that you want to be in. Okay, but you kind of have to think about it, you kind of have to visualize it. Maybe not the cosine inverse graph, but you've got to think about what it's returning and which quadrant you need to be in the end. Okay, now looking at the tangent graph, this one's pretty straightforward, because as we remember, the range is everything, which makes life a little bit easier. So remember that tangent looks like this, and we have asymptotes at pi over 2 and negative pi over 2. Okay, so it's kind of obvious that that's where we want our restricted domain to be. We're just going to look at one period of it. So our restricted domain is going to be negative pi over 2 to pi over 2. And our range is all reals. So we've got negative infinity to positive infinity. So when we look at tangent inverse, okay, our range, let's do domain first. Our domain is going to be all reals. And our range is going to be negative pi over 2 to pi over 2. I'm sorry, these should be round brackets. Let me fix that. Okay, these should be round brackets because we have asymptotes at negative pi over 2. Okay, and so our range is negative pi over 2 to pi over 2. All right, so we're going to have that, and then when we flip this, it's going to look like this and this. Okay, so same idea with tangent inverse. It's a little bit easier because your domain is everything, and just remember that it's going to return values in the fourth quadrant and the first quadrant. If you want to find any other values, just like with sine and cosine, then you're going to have to figure out what it would be in that quadrant.